I want to do an example of a video. I want to do a video of one of the examples that's similar to a homework problem, where we have two charges. I'm not even going to give the sizes of the charges because I just want to show you the way you approach the problem. So if you have two charges, one plus q, the other one minus q. So this is a dipole, as we talked about in class. And there's questions asking about what is the value of the electric field at different points. So one of them is to the right, one of them is to the left of these charges. So another one's over here. So in other words, what's the value of the electric field at these points marked x? Let's start with the center one. I have the plus. Let me switch this so that this one's negative and this one's positive, to make it consistent with the color that I'm using. Okay, so let's say we're directly in the middle of these two charges. The way you determine the electric field is you determine what's the electric field associated with the charge on the right acting on the center point marked x. And because it's a positive charge on the right here, it's going to cause an electric field that's pointed away from the charge. So at the point marked x, there's going to be electric field caused by the charge on the right that's going to be pointed to the left. Similarly, for the charge on the left, it's negative. So the electric field is going to point towards the charge because a positive test charge would be attracted to it. So it's going to be, due to the charge on the left, there's going to be electric field pointed to the left. So the way you approach this problem is you add the effect of the electric field caused by one of the charges to the electric field caused by the other one of the charges, this one plus that one, and that's how you get your result. In this case, it's going to not, the two are going to reinforce one another, because this one's going to cause, the one on the right is going to cause an electric field pointed left, and the one on the left is also going to cause an electric field that's pointed to the left, so the two will reinforce. So you got to add those two together. Now let's consider this point over here. All I'm going to say is this is not just a function of the electric field at this point x is not just a function of the negative q charge, it's also a function of the positive q charge. So you have to take both of them into account. I'm getting a lot of questions from students who are just using one of them. You have to use both of them. So you have to know the distance between here and here, which is whatever it is given in the problem. Then you have to know the distance between the x and the other charge, which is all the way over here. So you have to know these distances, and then you calculate the value and the directions of the electric field, and then add them or subtract them accordingly. They'll either be to the right or to the left, but they may not reinforce one another like they do in the center. All right, I hope these clues come in handy as you work on the first 5 problems of the homework. And the last few problems of the homework are associated with the video I did on the Padlet or the examples I gave in class on Zoom. Those should really help a lot with those problems. All right, good luck.